Good morning, ladies and gentlemen. Welcome those of you who are early risers just like me. Today we're going to be looking at a video on the quadratic formula. Now, this is going to be the last online teaching video that you're going to get before the break. I will be online later today. I should be streaming between 9 to 10, so you'll have that time to ask me questions. I will be streaming tomorrow while you're doing your Delta Math, and I should be online Friday for a little bit. However, Friday your grades are due, so that's what we're going to be doing most of the day. Let's quickly get into this. Again, I'm going to be online later on today. I'll be streaming any questions that you guys might have. So if you have a particular question as you start doing your homework, please just go ahead, write it down, and then send me a picture and I'll do it over on the stream. Now we're going to be looking at the quadratic formula. Quadratic formula is the ultimate way to find zeros. This will always give me an answer. I don't have to factor. I don't have to do anything. The only thing I have to do is begin with ax squared plus bx plus c equals to 0. So I do have to begin with the standard form. If I have an equation in standard form, the quadratic formula will give me an answer. Always. Every single time. The only problem here is that it can get very convoluted. Now, this is a very messy equation. That's negative b plus or minus the square root of b squared minus 4ac, everything over 2a. Plug in these things individually can get very, very messy very quick. Even if I'm trying to put it into a calculator, there's some things, there's order of operations that you have to follow. Some calculators do it, some don't. So it is very important that you learn to do this by hand. Now, I like to split the quadratic formula into 3 parts. We're going to have our negative b, or the discriminant, which is everything that's inside of the radical, and the over 2a. We're going to list them one by one, then we're going to put them together, and you'll get your answer. Now, let's do one so you see what I'm talking about. So let's try to do this. So I have something in standard form, and it has to be in standard form. If I had my 3 on the other side, if this was equals to negative 3, I would have to bring that over to the left side. I must have something that looks like this. It has to be equal to 0 or equal to nothing or equals to y. My left side has to be x squared plus 5x plus 3, right? So ax squared plus bx plus c. Now, I like to list my parts. I'm going to be looking for negative b. I'm going to be looking for b squared. I'm going to be looking for negative 4ac, and I'm going to be looking for 2a. Why those values? Well, if I look at my equation again, it looks like this. Negative b plus or minus the square root of b squared minus 4ac over 2a. So this part right here is that. This part right here is the inside of the radical, and the 2a is the 2a at the bottom, which should be 2a. Now, I'd like to split it up because this makes it a lot easier to see. Now, let's go ahead and for example, let's list the values here. So a in this case is 1, so a is here, b is here, c is here. So a is 1, b is 5, and c is 3. So if my b is positive 5, the opposite of b, my negative b, is going to be negative 5. If my b is 5, then b squared is going to be positive 25. Now I'm looking for negative 4ac. So a times c is 3, and that times negative 4 is going to be negative 12. 2a would be 2 times 1, so that would just be 2. Everything that I did was list these numbers individually and then just multiply for the individual parts. So negative b squared, negative 4ac, and 2a. Once I do that, all I have to do is put this back together. So this right here, I'm going to put together first. Now, this is what goes inside of the square root. This is called my discriminant. Now, my discriminant tells me whether I can continue or not. If this number is negative, I could stop. There are no real solutions. So I have 25 minus 12, and that's going to give me 13. So that's the number that's going to go inside of the radical. We talked yesterday about the fact that if I have a negative number inside of the radical, then I have no real solutions. So this number here can't be negative. Well, I have a positive 13, so I'll continue. Now I'm going to plug all of this information inside of the equation. So I have negative b, my negative b is negative 5, and then I'll have plus or minus whatever goes inside of the radical, so plus or minus my discriminant, which in this case is 13, and all of this over 2a, which we found out was 2. Now these are my solutions. Now I have to understand that this means two things. This means negative 5 plus the square root of 13 over 2, and negative 5 minus the square root of 13 over 2. So I need to rewrite this as x is equal to negative 5 plus the square root of 13 over 2, and x is equal to negative 5 minus the square root of 13 over 2. And this will be my two zeros. Now, this looks extremely messy, and I get it. This is one of those things that it might take you practice to get used to and to get good at, but it will give you, there's no way I could find these answers by just doing it in my head. There's no way. I can't even find this answer by making a table. I would never get negative 5 plus the square root of 13 over 2, right? I don't even know what kind of value that is. This equation will always give me the answer, and they don't necessarily always have to be messy. Let's say that I had an equation that I could factor, but I just choose not to. I like the way this equation works, and I want to go ahead and use it, and I want to get good at it. So even though I know the next one is factorable, I'm just going to plug everything inside of the equation. So I'll have, let's say number 2 is x squared plus 5x minus 6. Well, actually, let's look at it. Is this factorable? I need two numbers that multiply to negative 6 and add up to positive 5. So potentially, I could just rewrite this in its factor form, which is xx. I need a negative and a positive number, so this would be positive 6 and negative 1. And that would add up to 5, right? So I would have that x is equal to negative 6 and x is equal to positive 1. I could do that. Now, the challenge here is, will I get the same answer if I use my quadratic formula? I should. So let's go ahead and try that again. I'll rewrite the formula so you guys get used to it. And again, this is negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. So let's list my individual parts again. This is a, this is b, and this is c. So a, b, and c. My a is 1, my b is 5, my c is negative 6. And I do encourage you, if you want to pause the video, go ahead and do it on your own. See if you get the same answer, see if you can do it, and then come back, watch the rest of the video, or just go ahead and follow. So I want to list the 4 things that I'm going to use. Negative b, b squared, negative 4ac, and 2a. And again, remember that my discriminant is going to go together. So negative b, first of all, my regular b is 5. I need the opposite of that, so that'll be negative 5. B squared is going to be 5 squared, which will be 25. And negative 4ac would be a times c, which is 1 times negative 6, which is negative 6, times negative 4, and that gives me positive 24. And 2a is going to be 2 times 1, which is 2. Well, I need to get my discriminant together. So 25 plus 24 is 49. I will plug everything inside the quadratic formula. Now I need negative b first, so that's going to be negative 5, and that will be plus or minus the square root of, I just need my discriminant. My discriminant in this case is 49, and all of that divided by 2. Well, I can't stop here because 49 has a square root, so this would be the same thing as saying negative 5 plus or minus 7, because the square root of 49 is 7. All of that divided by 2. Again, I need to make sure that everything here can be done. So I could for sure do negative 5 plus 7 and negative 5 minus 7. So I'm going to go ahead and split this into 2 parts. I'll have on one side negative 5 plus 7 divided by 2. And then I'll have negative 5 minus 7 divided by 2. Well, if my calculations are correct, negative 5 plus 7 is positive 2. And positive 2 divided by 2 is 1. And negative 5 minus 7 is negative 12. Negative 12 divided by 2 is negative 6. So my x-intercepts in this case are positive 1 and negative 6. And that is what I should have gotten in the beginning. So I can see that I have negative 6, 1, and 1. Now this is why it's very important to learn to factor. Now I don't have to do the whole quadratic formula if I could just go ahead and factor this. A lot of people do like to though, and there's nothing wrong with using the formula because you don't have to worry about whether you have something that's factorable or you don't. You just plug it in, you get an answer, and you're done. Let's do one that doesn't have an answer so you can see what happens when you have discriminant that is negative. So this will be the last one, and then again I'll be online at 9 a.m. and you can ask me any questions then. So number 3, let's say I have something like 2x squared plus 3x plus 5 equals to 0. Again, I'm going to identify. I have A, B, and C. A, B, and C. My A is 2, my B is 3, my C is 5. Let's write the parts that matter. Negative B, B squared, negative 4AC, and, change color, and 2A. Well, the opposite of positive 3, which is my B, would be negative 3. My B squared is going to be 3 squared, which is 9. Negative 4AC is going to be negative 4 times 2 times 5, which is going to be negative 40. And 2A is going to be 2 times 2, which is 4. Now, before I do anything, I need to check my discriminant. Now, in this case, my discriminant is 9 minus 40. 9 minus 40 is equal to negative 31. This is negative. This is the number that goes inside of the radical. Put this inside of a radical. It'll tell you error. So I can stop here. I know now, because I know that discriminant cannot be negative, that this has no real solutions. So no real roots. And I'm done. Okay, and those are the basic 3 examples of using the quadratic formula. That's what could happen. I could A, get something that looks very, very messy, right? Plus or minus the square root of something. B, I could get something that actually simplifies because it was factorable to begin with. Or C, something that stops halfway. I don't have to do it because it has no actual real roots. Those are the 3 that you have to worry about. And again, those are going to be time-stamped, and as you're doing your homework, just please go ahead and look for them and try to figure out which one is the one that you need. Make sure that you take notes. You're going to submit your notes on Google Classroom. You're going to submit your work on Delta Math, and then again I'll be online in about an hour and 40 something minutes, and we can chat and we can talk about the problems that you might be having. All right, have a good rest of the morning, guys.